Hi, this is Module 6, Lesson 1, which is mass movement. So we're going to talk about ground movement with mass movement, so like landslides, mudslides, things like that. All right, so the focus question is what I want you guys to think about while we're going through. So what can we do to reduce the risk that mass movements pose to people? So what can people do to reduce their risk of being in harm's way or increasing the chances that something like that would happen? So just to review, gravity is usually what causes all these mass movements. So they're mainly formed by gravity. But gravity is just the force that is exerted on every single object, whether it's an atom all the way to entire planets. But it's just due to their mass. So the more mass something has, the more gravity it has, and the more that gravity affects it. All right, so mass movement just means that land is moving. So there's soil and weathering that usually cause things to loosen up. And then we have a mass movement, which is just that movement of land down the hill. And so things that factor into mass movements would be the amount of rainfall. So that's basically climate. And then also what kind of weathering is occurring. So is there a lot of weathering? Is there a little bit of weathering? What kind of rock type is there? So things that are like a sandy sandstone type material is going to weather faster and be more slippery than something that's granite, for example. All right, so here's kind of a big example of a landslide. So you can see that quite a bit of land has moved down. It looks like it ruined a couple buildings. I'm not sure if there's anything in here, but there, the soil just, maybe there wasn't a lot of vegetation. You can see there is some vegetation, but very small amount of grass. Just looking at the dirt, it looks really sandy. So it probably is not very stable. There could have been just a lot of water. Maybe there was a earthquake or something occurred, but that's quite a bit of land that has moved. All right, so there's 4 factors that factor into whether or not mass movements occur. So one is just how much weight does the material weigh. So saturated dirt that's full of water, is going to weigh a lot more than dirt that's unsaturated. And then how steep is the slope? So then next we look at resistance to it sliding or flowing. So how cohesive is it? Is it stuck together like the little water droplets that you see in the bottom right corner? Or is it stuck to bedrock? Is it really loose on top of bedrock? Things like that. So basically, how resistant is it to sliding down the hill? That's really important. And then there needs to be a trigger. So there needs to be excessive rainfall. There needs to be an earthquake, something that loosens up the ground. And water increases this. So if you increase water, you increase the weight, but you also increase the slipperiness of it. And then you've got gravity pulling everything down. So a couple examples here, you can see earthquake happened and didn't necessarily cause a landslide here, but it could have triggered something somewhere else, like the picture on the right. So you can see that this is probably due to oversaturation. So it looks pretty wet here. They're probably, it was loose soil, maybe sand on top of bedrock. And then not a lot of vegetation, a little bit, but not a lot. And then just basically moved. All right, so there are different types of mass movement. One is called creep. And so this is an example of creep, both of these. And so you really don't notice this until a lot of time has gone by. And you can see this all around. So maybe you have a retaining wall. Maybe you see this fence. If you drive out anywhere around here and you look at fences that have been up for a while, you'll see that. So you'll see them tipping, or maybe even like telephone lines, power lines. You'll see them kind of, maybe not so much as this, but you'll see them kind of tipped. And that's just because the ground underneath is slowly moving down because of gravity. And you can see that here. So notice the trees, they compensate. So they grow upright. They grow based on gravity. So if the ground here is slowly moving down the hill, then the tree is going to slowly be tipping. Well, the tree is going to compensate by changing its direction of growth. So it's going to continue to grow upright as the ground moves. So we're going to get kind of this curvature of trees. And that's just because, like I said, the ground is moving down and the tree is compensating for that. So that's the only time that you'll see that creep occurring. it's very, very slow. So you have to see over time, things will start to shift, retaining walls will start to give, that kind of stuff. All right, so you can see that creep is occurring here. So the ground is sliding down, and you can see that there's been uplift here. So you've got these layers that are not horizontal, so they've been kind of tipped up. And then you've got this transported soil on top. So this soil, remember, transported means that it didn't form here. Some of this could be residual, but some of this could also be transported because the ground is slowly moving down. So this is a great example of creep. You can see this fence post has started to kind of tip over. The trees would be compensating. These power poles are tipping over, and so very commonly found with creep. All right, and then mud flow. So mud flow, creep is the slowest, and then we're going to kind of build up to the fastest here. So a mud flow is a very the ground is very saturated, or maybe there's a volcanic eruption or something. But mud is very heavy and generally moves slow. So the earth flows fairly slow. But when you add a lot of water into it, so think of like creep occurring, but then you've got all this water added to it, and maybe a lot of melting. Maybe there's a volcanic eruption, you have like a ton of melting. Then you're going to get a pretty rapid mud flow. So you can see this avalanche. It's a debris flow from an earthquake. And so it was saturated, so it created a lot of mud. And then same with this. So you can see that quite a bit of mud flowing, and that could be just due to oversaturation, or it could be due to some kind of trigger like an earthquake or volcanic eruption or something. All right, so lahar is a special type of mud flow, which is caused by eruption. So I mentioned, think about like Mount St. Helens, for example, when that erupted, it melted a lot of snow fast. And so when that happened, when it melted fast, that produced a lot of mud and flow with the ash down into the valleys. And so that's called a lahar, and that moves really fast. Mud flows are extremely dangerous. They're kind of hard to move out of the way from. It's not something that you could outrun. They're very, very fast. And they occur in mountainous regions. So you wouldn't see a mud flow, or a mud flow wouldn't necessarily be dangerous in a flat area unless you're in between two hills. All right, and then we've got a landslide. So here you can see this is a landslide that partially covered Highway 1. So I think this was down near Ventura. But you can see that basically the debris went out over the road. And this is usually due to really steep cutting of banks to make roads. So sometimes it's inevitable. We get these a lot on 299 towards Eureka. But basically just the ground gives way, and it could be just due to the fact that there's lots of rain. It's super steep. It's just gives way over time. And then you can see here, this is extremely dangerous situation, but they've got, the road has given way, and basically they are driving on a little tiny narrow road now instead. So usually this happens, landslides are usually on really steep banks. And then we've got slump. So slump is triggered oftentimes by a lot of rain, and it's really, you can kind of notice this kind of U shape. That's typical of slump. And so just a little bit of land kind of moves quickly. It's usually not too much land. And this could also be due to river. So a river could be flowing in the area, and the river cutting into the bank constantly cuts away, so that part of it kind of just slumps down. But that's usually always due to water. All right, and then avalanche. An avalanche is just a really fast flow of a lot of snow. And snow laid on top of other snow, especially if the snow is partially melted and then you get fresh snow on top, it makes this really slippery kind of surface. And so that snow can be triggered by simply just gravity, or it could be triggered by something, earth movement or something. But it's very devastating. So, it definitely kills you if you're not careful or you're in the path. But it can blow over trees. It's just very, very heavy. So that can be very dangerous as well. And then we've got, if we look at cliffs, we've got really weathered rock here, and it's very, very steep. And so that oftentimes, like on 299, for example, that often crumbles down and goes into the road. And so you can see that here. Obviously, these are pretty big rocks, and it's across a road. So that's very common in areas that have very steep slopes. All right, and most of the time, these kinds of things are due to human activity. So rainfall, obviously, we can't control, but there's a road that's cut into this steep bank. Well, the steep bank, natural weathering is going to occur, and so naturally, the rocks are going to crumble and weather and break. But a lot of this is due to the fact that we cut so steep on the hills that it's inevitable that that's going to happen. So that does cause some mass movement. And the best way to reduce that, the number of disasters, is to either not build there or maybe have some type of retaining wall, some netting to catch some of the rocks, or just not generally building on steep slopes in the first place, is kind of how to protect people. So staying away from those types of areas. All right, and then this is just a short video on different types of mass movements.
Slip sliding away, slip sliding away. You know the nearer your destination, the more you slip sliding away. I know a man, he came from my hometown. He wore his passion for his woman like a thorny crown. He said, Dolores, I live in fear. My love for you is so overpowering, I'm afraid that I will disappear. Slip sliding away, slip sliding away. You know the nearer your destination, the more you slip sliding away. And I know a woman became a wife. These are the very words she uses to describe her life. She said a good day ain't got no more. She said a bad day's when I lie in bed and think of things that might have been. Slip sliding away, slip sliding away. You know the nearer your destination, the more you slip sliding away. And I know a father who had a son. He longed to tell him all the reasons for the things he'd done. He came a long way just to explain. Kissed his boy as he lay sleeping, then he turned around and headed home again. He slip sliding, slip sliding away. You know the nearer your destination, the more you slip sliding away.
A mountain begins to move, and for a contractor and his son, there's only one option: get out of the way fast. They had just gone head-to-head with one of nature's most powerful and destructive forces, a landslide.
Oh, you slip sliding away, slip sliding away, slip sliding away. You know the nearer your destination, the more you slip sliding away.
All right, I hope you enjoyed, and I will see you next time.